So good afternoon. Thank you for joining us. Today we are going to be talking about high performance airport apron lighting and how to specify the best solutions. This is our fourth webinar in the series. So before we get started, just a little bit of webinar protocol for any of you that may not have used Zoom in a little while. So you're all muted. Please say hello to us in the chat. And if you have any questions, please put them into the Q&A box. Just a note, in the chat box, there's a little blue box that says who you're saying hello to. So you can say hello to the panelists or you can say hello to everyone. So if you want to say hi to everyone now, just make sure you've clicked everyone. After the webinar, we'll send out a follow-up email with a link to the recording so you can rewatch anything or share with any of your colleagues that this may be useful to. And any resources that we mentioned during the webinar will also be linked in there. And after the webinar, there'll be a quick survey with 2 questions. We'd just like to know how you think we've done today. So we'll start off with some introductions to our wonderful presenters and a little bit about midstream lighting. And then we'll go into the main presentation where we'll be covering the mechanical, lighting and electrical characteristics and also the documents required. At the end, we will have 10 minutes for questions, but if we get a lot of questions like we have in previous sessions, we may run over a little bit. So first off, our first presenter is Yuli Grigg, one of the co-founders of Midstream Lighting and commercial director. Yuli's worked in aviation projects for over 15 years and over hundreds of projects and all over the world. And we're also joined by Paolo, our other co-founder and technical director of Midstream. And Paolo really is the expert on all things LED, especially high-powered products. So Midstream Lighting, we are a high-powered LED floodlighting manufacturer and solutions provider. We've completed, as I've mentioned, hundreds of projects worldwide in over 150 airports. And we don't just sell products, we offer the whole solution. So that's everything from the lighting design right at the beginning of your project to any consultation you may need. We obviously manufacture those products and we offer shipping and logistics. And we also offer training and we like to share our knowledge with all of you. And that's why we're here today. So over to you, Yuli.
Thanks very much, Sophie. So today we are talking about specification writing and how to really maximize the opportunity to bring about the best products in and the best solutions actually for your project. And the reason we think this is important is that ultimately any kind of tender or request for quotations is used to provide a competitive pressure to ensure that the pricing is the best you can get. And that's perfect. That's what it's there for, and it's very much needed in the market. However, what we have to ensure, though, as project owners, is that we are using that to really bring about competitive pressures amongst products which we need. And the worst thing that we can always find ourselves in is if we haven't written a tender specification properly, or tightly as sometimes it's called, we can end up having low cost, low quality products in there. Now, of course, there are lots of reasons why low cost or low quality products might be the right solution for different applications. But when we're talking about aviation and we're talking about airport aprons, the reality is that's not the right place for cheap and cheerful products. These are technical requirements that we're trying to meet, and so we need a technical solution. So writing the documentation for a tender is very important, because if you don't write it correctly, you can end up with things that you don't want. And then it's very difficult to unwind that situation, because if you assigned the criteria to pricing or a large part of pricing, you could end up having products which don't quite meet your requirements. How it normally happens is that a project is delivered on the basis of documentation, and that documentation is built on the basis of project concepts, or when it comes to lighting, the lighting plans and the lighting projects. So the lighting projects will then should ultimately lead to a type of specification. Now, for this particular webinar, we've decided that we're going to have a kind of a fireside chat. So I'm going to be asking Paolo, who's our technical lead, about some of the things that we typically propose to put into specifications. And you are able to download our specification guide, which has all-encompassing information, which can be used to specify most of our products. Now, today we're going to be using our Master MO4 product as kind of the basis for this webinar, but there are different specs for different products. And so what we've done is we've put together a guide that goes through all the different elements of a product that you may want to put into your specification if it's relevant to you. And the guide explains why actually it needs to be implemented, that particular specification, and what happens if you don't use it, what the risks are of not requesting for that particular aspect of a product technical specification or characteristic. So here on the slide, you can see, for example, we've broken it down into different elements, but this is the mechanical characteristics. And these are all the things that we think are important. There's a detailed explanation in one column. Another column will talk about why that's important for an airport apron. And then the opposite of that, what happens if we don't implement that? And for the purposes of this presentation, we're just going to take a few of these things and talk through them. If you want to have a fuller picture, then obviously you can look at the guide, which is available soon to be downloaded. So I've just selected from mechanical characteristics 3 things which I think are important. They're not more important than others, but these are just the things that I've selected to discuss during this presentation. And the first one is, we like to say that stainless steel body of the luminaire in 316 grade, so the highest level of grade of stainless steel, is very important to ensure really the durability of the product in harsh environments. And of course, this mostly relates to environments which have humidity in the air, or coastal or island airports, anybody that's close to kind of any body of water with salinity that can basically create a more aggressive corrosive environment. But here's a question. So Paolo, you're the expert. I'm more on the commercial side. What I always want to know is, okay, stainless steel, if we compare that, for example, to a painted aluminum or aluminium body, the chassis of the product, is that almost the same? Is it very similar?
Let's say, Yuri, that in the short run, the result is almost the same. So you could have a lower grade metal which received an appropriate coating, like you could have a low grade steel with galvanization. It will be protected from external factors, from salt mist. Same thing goes with a die-casted heat sink or body of a luminaire made out of aluminum alloy, and the die-cast alloy also have quite a lot of copper content. Then they're usually coated with polyester in order to be protected from the environment. The thing that makes the big difference between building it in 316 steel is that all these other solutions, they rely completely on the coating, on the protection. So all it takes is one chip for that to go sideways, some abrasion. For example, I don't know, you have an airport in the seafront in say in the Gulf, where it's constantly windy with dust.
Let's say
and
Kuwait,
sand.
for example. We have some guests from Kuwait.
That coating is not going to last for the whole lifetime of the product, because it's going to be thinned down by the wind with dust. And once that metal underneath gets exposed, if you expose mild steel on a coastal area, that will go in 6 months. It will start to defoliate and will actually carve into the metal. Stainless steel, especially 316, which is, I mean, it's the highest grade for industrial commercial application. Let's say there are other grades of steel which are going to be for very specific applications that can resist to different acids and all of that. But 316 steel will develop some surface corrosion, but will never eat through the metal. So you will never compromise the solidity of the product. While if you go down If you go with galvanized mild steel, die-casted aluminum, once you expose that metal, the corrosion will actually attack the structure. So it is an insurance, let's say, because you still have it painted, you still have a surface protection, but the material itself will be resistant.
So is it a wives' tale? Is like a story that, if you get some chip or scratch in the paint, you can see sort of invisible corrosion that takes place under the paint that you won't actually be able to see, but it's actually eating all the metalwork inside. Does that happen, or is that sort of just a scary story?
Generally, you'll start see bubbles in the paint. So you start see bubbles in the paint, it means something is happening underneath, and then you remove the paint, you'll find out you have a hole under there. Like you will see in old cars in coastal areas. But even even with the 316 stainless steel, you could get the paint to lift off completely from the luminaire. Also because the downside of stainless steel is that the paint doesn't stick to it that well as with mild steel. But if the paint is removed, then the steel is exposed and will stay like that forever.
And could bird excrement, could that sort of bird waste, could that eat through paint? Is that a problem?
Yes, bird droppings are actually one of the worst stuff for luminaires. Depending on types and size of birds, they can create quite a lot of problems. Again, coastal areas, you have seagulls, which make pretty considerable size droppings on the luminaires. So it's always better also to have bird spikes on it.
Yeah, interesting. Well, there's an old story about a nuclear accident at Sellafield in the UK, and the pigeons were eating the food around the nuclear waste, and then their droppings were being carried across with nuclear material inside. Anyway, that's a different story.
Lovely.
Okay, so IP66, that's an interesting question because, well, we all kind of know IP66 is there to prevent water ingress, dust ingress, so it's very good. But is IP66 much better than IP65?
Well, I mean, let's go back. Like the IP ratings, they're made of 2 digits. One is related to water, the other one solid particles. In this case, the first 6 is the one related to very fine dust, which is the highest you can get in IP ratings. The second digit describes what type of water will the luminaire resist to. So IP66 is where you get, the last 6 is where you get in the range of high pressure sprays. So you could take a fire hydrant to the luminaire in any angle, and you ensure that water will not be able to get in the product. While IP66 is a low pressure spray. This guarantees that, any angle, you can wash the luminaires, like extremely heavy rain, you have enhanced resistance. And let's say that the 6 is the highest, the 66 is the highest resistance to sprays, because once you go a step above IP67, you're no longer talking about sprays, but you're talking about submerging the product into water. So IP67 and 68, as well as 69, 69K, and all the special ones, they only talk about putting a product in water.
Which we don't care about, right? Because we're on a mast 30 meters in the air.
Yeah, if the mast were submerged, we'd have bigger problems to deal with.
Right.
But also, this means that if you have a IP67 certified product, it doesn't guarantee that you would pass 66. Because if you imagine that you design a gasket that can resist to like a pressure water that I spray on it, or it resists me putting it in a 1/2 meter deep bucket, one that doesn't guarantee the other. So 66, I believe, for this type of product is the best you can get. And getting a 67 is not an upgrade.
Okay, is 65 a downgrade? Is 65 worse?
It is definitely a downgrade, yes.
Okay. So
the severity of the test that needs to pass to get a 65 IP65 stamp is far easier.
So that's why we recommend 66, and you can read more about that in our guide. So next point on this slide is maximum dimensions. That's we're basically saying we don't want the product to be too big. And the reason we don't want it too big is because a large product with a large surface area creates a sail area, so we can have issues about stability of the mast, and it probably leads into its weight as well, but not necessarily. But what we're trying to avoid is to have a very large sail area, a very large thing, because that could really have an effect on the structural integrity of a high mast during winds. And when we talk about retrofit, that's a critical point. When we're talking about new construction, that's a commercial point, because a mast will be designed according to the sail area, the surface area basically of the luminaires, right? So the question here is, how much thought do we need to think about when we're specifying the maximum dimensions?
Well, actually, let me just add to that, because the maximum dimension influences all the things you just mentioned, but also influences the practical installation of the luminaires especially in retrofit projects, because sometimes you're dealing with limited mounting points on masts. Right. So if you have a compact enough luminaire, you'll be able to use the same point for 2 fixtures, for example, and you'll be able to rotate and orientate them without them interfering with each other. Because otherwise you could get to some situations where you cannot aim the luminaires as in a lighting project, because they would touch each other at those angles. Right. Yeah, or they cannot stack one on top of the other because they will mask each other. And that, I mean, we've seen it in practical terms and in various airports when they didn't want to change the infrastructure, but upgrading the lighting system was difficult due to size of the proposed luminaires. Said that, I've kind of forgot the question, sorry.
So just basically saying, is this mainly relating to the existing mast, the new construction from a cost standpoint and technical standpoint? But how much analysis do we need to make on this? Do we need to do any structural engineering?
Well, let's say that, yeah, an important thing that you said, because it is a lot related to the windage, because if you have an existing mast that was designed up to a certain windage area that you can install on the top. So if you have a proposal to install luminaires with a lower windage than before, you can carry on and do it. If you're always within the limits that the mast was designed for, unless you have doubts that the mast is not in good shape, then you still need to do a survey on it. But otherwise, you could just go ahead and install it. If you surpass the windage or the weight, then you will need to do a structural analysis of the mast to make sure that it can actually take those products.
And does this at all relate into sort of installation? If it's too big a product, do you need 2 people to lift it up and to connect it?
I mean, there are certain limits which are actually set by normatives on how many people need to lift the product. If it's above 30 kilos, for example, that's more due to the weight itself. Then, yeah, of course, the practical side, even though there's not a normative that tells you that if a product is 1 meter by 1 meter, you need 2 people, you still need 2 people because you won't be able to handle it otherwise. And that, I mean, it's particularly bad, let's say, if you are doing a retrofit on static masts. If you're working on the ground, it's easier. But with static mast, it means you need to carry those products up on a platform. And if you can only fit one at a time, it means you need to keep on going up and down with the platform, and your installation times become very long.
So that takes us to the next point, which is maximum weight. And we always say, okay, well, we've designed something, for example, with our Master 04 product. We'll put that or near about as the maximum weight, because we really want to restrict having very heavy products. And we know they do exist. Some of them are huge and they're just not suitable for structures or the quantity that we've designed with, right?
Yeah, I mean, with the M04, we focused a lot on the lightweight, and that is achieved through a specific design of the heatsink, a specific material of the heatsinks that allows it to be that lightweight. And yeah, especially again, this is the biggest focus on retrofit, again, to avoid redoing surveys on the masts, and also, I mean, generally when you're putting weight on the top of a very tall steel structure, the less, the better. So there's only advantages.
Okay. So a couple more on the mechanical side. Tempered glass screen enclosures. This is a glass screen that we put in front of the lenses. Can you tell me why it should be tempered, firstly, and do we really need a glass enclosure?
Yeah, so this glass screen that we install in front of our lights, well, it needs to be tempered because non-tempered glass is extremely delicate and brittle. Tempered glass can resist to high energy impacts. In our case, we certify to IK09, which is, well, I'm gonna say the detail, but it's a steel ball dropped on the glass from quite big height. So it's actually extremely resistant. It is critical, and we actually encounter problems ourselves before we've implemented into our products, because this tempered glass screen avoids particles to deposit directly onto the lenses, whether they are PMMA or polycarbonate. And basically, if you're in an environment with a lot of dust or a lot of pollution, instead of getting the deposit directly on a lens which sits millimeters away from your LEDs, you get it centimeters away, and well, you avoid that mechanism of heating dirt with the light beam. Light is a short wave, and when it hits some material, it becomes long wave heat. So you turn dirt into heat, localized close to the LEDs, and it will cause failures. While
Because heat's the worst enemy for LEDs, right?
it's not even for the LEDs themselves, it's for the plastics of the optics. You reach temperatures which degrade and destroy your optics. By doing it with the glass, you move it far away, and also the spread of the light is across a far larger area than directly in front of the LED chip. So this heating up mechanism, it's far lower. And also being the glass perfectly flat, the deposit is far less, because instead of an irregular surface when dirt can just really finds a way to stick, this is a flat glass. When it rains, it washes off. It's easier to clean. It's got many advantages. In our specific case, we used a special anti-reflective, quite expensive, honestly, tempered glass compared to the standard tempered glass that you can use in street lights for low power, because every percentage point that you lose by reflecting the light back into the fixture makes quite a big difference into a high power product, and also into its working temperature. Because if you reflect back light inside of the luminaire, you raise the internal temperature.
Yeah, so now we think it's highly critical to have that there as a feature in the product. We recommend it really very strongly. Then one more here is the environmental testing. This is basically to say that we want to have the product that has evidence that it can survive in a salt mist environment. And it's normally done through testing the chamber with lots of salt mist spray every 2 hours. I don't think there's much more to say about that, except for to say that it shows the product is well built to survive saline corrosion.
Yeah.
Yeah. Okay, let's move on because I'm conscious of time. The next section in our guide will be lighting characteristics. So we have the mechanical, now a couple of things on lighting. And again, there's the same format, different columns talk about what, why, and why not. We talk here about minimum efficacy of 135 lumens per watt. Now, yes, has to be certified with a LM79 certificate or an equivalent, which basically shows that it actually does that. But 135, why do we select that number? Is that kind of where it should be recently? Is that the latest level?
Yeah, let's say that 135. Okay, it is an arbitrary number, but it's where you put the divide in the latest generation of luminaires. Then you might have 135, 140, 145, depending on the optics, because you know the more you modify the optics, the more you lose light efficiency in there. But yeah, it is a reasonable value to put a divide for the last generation of products.
Just
And
basically saying it's got to be a high performance product, high efficiency product.
And this number though is net of all losses, net of the driver, optical losses, because a lot of stuff you read around says 200 lumen per watt. That's just the chip without any losses at 25 degrees junction temperature. They're all, marketing. And it's sorry, I said it in a bad way, marketing. I saw you look, Sophie. But yeah, when we say backed by LM79 certificate or an European equivalent, it means it's actually measured, not just a claim. It's measured because also in order to do a lighting simulation with a photometric file from a product, you must have done a laboratory test to actually get your photometric file. So
and by the way, I just want to make this abundantly clear to all of our listeners that we have come across in major airports in Western Europe submissions for tenders of quite big companies that were unable to provide an LM79 certificate because the products were theoretical in nature. They had planned to create them in the future. They thought this was the optic they were going to use, but they'd never done a testing. And that's really a risk that anybody who is accepting this solution, that they will end up delivering that performance. And it's not an easy task. We've been plugging away at this product, this technology for 15 years almost. And, it's not an easy job to create a product with specific characteristics on the luminaire output, on efficiency, and all of those things. So it's hard work, and it's not a solution that can be easily done. So the point here is that we use 135 as a minimum to basically cut off anything that's not performing very well. So that's where we are. Now, the next point is interesting because we say minimum net lumen output of 60,000 lumens. So that's already starting to get kind of into a land of specific project work, right? Because yes, it's for the Master 04, but
yeah, let's say that, okay, this 60,000 lumen minimum, it's based on this particular product. Let's say that this is a true value for most of the Central European and UK type of configurations, because the amount of lumens that you need, it's always a balance of how many fixtures do I want on the mast to ensure that I can orientate well and I have redundancy, and I have to, of course, reach the light levels. So it's always influenced by the type of aprons I'm lighting, the height of the mast, the spacing. So in some airports, this net lumen output might not be through. You might need 150,000 because you have 45-meter mast with gigantic aprons and different spacing. So yeah, everything also in regards to the ULR, the upward light ratio, less than 5% that we put down here with asymmetric optics. These are all details that need to be in a lighting simulation. That has to be a fundamental part of a specification when when you're trying to get offers, proposals for an airport. There needs to be a base lighting design for it, because otherwise it's just theoretical talk.
So basically, we start with the project requirements, then we have a lighting study to meet those project requirements, and then the specification is built on top of the lighting study.
Exactly, because it's a mix of just qualitative characteristics of the products used, like the materials and everything, and the performance of it. Because you don't want to just specify that you want a 400-watt luminaire, but don't specify how many you want. It's because it needs to be based over a project. You need to first prove that you can do this design with these characteristics, and then your product needs to meet all these other requirements.
And what happens sort of when people look at our guide? I think the important thing we want to say is when you're looking at our guide, it's kind of a pick and mix. So it may be suitable for you to use the stainless steel, maybe it isn't, because you're doing a lighting study in a warehouse. but you might want to use the asymmetric optics with ULR. Or actually, if it's a hanger, you don't want asymmetric optics. So it's kind of choose the sections that you need specifically for your project, and don't assume it's all or nothing.
Exactly.
It's kind of a pick and mix. Great. Okay. So then electrical characteristics. I think I'm going to speed up on this section because I'm conscious of time, and we kind of want to finish off in the next 8 minutes. We've talked about a replaceable external, I should say, not eternal. Eternal would be great.
I wish it was eternal.
Yeah, that'd be great. If you can find one, definitely go for it. But it's an external replaceable Type 2 and 3 AC surge protection device. So I think we are one of the first really in the industry to start to be a proponent of this, to say that, okay, guys, you know, all LED floodlights and almost all the good ones have an internal surge protection inside the driver. But actually, for better protection, let's have an external one, right, Paolo? So just mention a few words on that.
Yeah, so we always push for installation of an external SPD, specifically Type +2, 2+3, which means an SPD which can cover a certain range of surges, certain amplitude and intensity of surges, which are the ones that mostly affect the electronic drivers of the LEDs, which are actually the first cause of failure of LED drivers, or actually of electronic drivers per se. And since the luminaires are always installed at the end of a line, so on top of a mast, that it's actually the perfect spot to be on the receiving end of these surges, which can originate from various amount of devices, like a little bit of defective contactor, motor for AC or something. There's a lot of things that can create surges when they either start or stop working. And these little surges, after 1 year or even 6 months, depending on how many you have, they will break your electronics. So the drivers do have a surge protector inside, but it's not replaceable. And surge protectors can only take a finite amount of surges before they become useless, they break. So by having an external one, which you can, well, an external one is actually far more performing than the internal ones in the drivers. So already can take a wider range and many more surges than an internal one. And they come with LEDs on top, which show if they are at end of life. So you can replace them during your yearly or twice like every 2-year maintenance cycle. And they're very inexpensive. And just one surge protector per mast might save us a lot of money on replacing drivers down the road.
It's really, I think it's a huge upgrade to
Huge, yeah.
an internal one, and it's a low-cost upgrade. So it really comes with the highest recommendation from us to start employing these external replaceable SPDs. And then we'd also talk about a DALI 2 or a D4i smart driver. There's probably not much more to say about this, Paolo, than we think that you should be using the latest technology. And either a DALI 2 or a D4i type of driver will give you a lot of feedback about your system. It's easy to integrate with controls. It's basically a smart system which allows you to get data which you can analyze, make decisions on. You can implement settings such as dimming or grouping.
Yeah, and even if you don't plan to use it straight away, once you have luminaires with the D4i capability installed, you can always do it. In the second stage, you can implement a control system. But if you don't have them, you will never be able to do that.
Exactly. So in a few years' time, you might have budget for a control system, or you want to implement any kind of smart systems around that. Then you just this plug and play. So I think this is the last section, right, Sophie?
Yeah.
Yeah. Documents required. So there's a list of the things that we typically say are important to provide as part of the submission that any scrupulous or diligent project manager should look for when looking at submissions of lighting companies or providers of the lighting systems. Obviously, the ISO 9001 and 14001 are quality management, environmental management systems, which are audited. This is important to demonstrate that the company is complying with the latest requirements from the International Standards Organization. NEC and CB, now that's product specific, right?
Yeah, NEC and CB certifications mean that, well, your products have been, specifically our products or products of our category, have been developed following the EN and IEC normatives regulating how you build a high power LED floodlight. And they've been tested against it every aspect. So you have passed your electrical safety, IP tests, photobiological safety, EMC and EMF, the big range of testing. And not only that, it also means that your factory has passed the test, and your factory is constantly audited, at least once a year. And also one product per type is taken without, without a surprise from your production line, and it's tested again against all your normatives. So these two marks ensure that what you do not only is compliant, but it's always compliant. And it's also like the CB certification, for example, they are the same thing, honestly. They're two marks, but in order to achieve them, you do the same testing. But CB, it's actually very widely used also for customs. So a lot of customs, when importing electronic components, will ask you for a CB certificate.
And it's not easy to achieve, right? I remember like when we were going through the NX certification, 6 months process.
Yeah, it takes quite a lot, especially if you have a lot of variants, a lot of models to include in a family. You need to test a lot of things. It's quite
and I think that means that not only is that a quality product, but it's a product that's, that the manufacturers have spent the time and effort to actually go and have it independently tested. They've put the money behind it. They've put the time. It's not something they just made yesterday, and you're the first ones to put it on your mast, which you really don't want. And that leads nicely into the fact that actually, when we talk about apron floodlighting, with a minute left, I just want to say that experience is very important when it comes to working with airports, because you learn through doing so many things about how products should be built, how it should be designed, how lighting studies should be done correctly. So working with a company that's never worked an airport project before, that's a big risk that somebody's taking by doing that. And we once were the first company in the world to start working on LED systems in airports. We were the first to complete full international apron upgrades in the UK, but around the world too. And we've made the mistakes, we've learned from them, and we've, developed products and solutions and thinking over time. So that's a journey that mustn't be overlooked. So I think having at least 5 international airport projects probably gives you a good supplier that knows what they're doing. And there are enough out there to have a good competition on the price. And of course, finally, lighting calculations which comply with ICAO, backed up by lab reports from photometric files, are a key to ensure that you are building your specification from a set of products that actually deliver the compliance you need on the apron. Do you want to add anything else, Paolo? I think that's about it, right, on that?
Yeah, I think it is, honestly. Maybe I don't know if we finish with this, we can go on with the questions.
Yeah, wonderful. So thank you very much, Yuli and Paolo. That was really useful. So everything that we've mentioned today and that's been on the slides are in our specification guide. So we're just putting the finishing touches on it. It's not quite ready yet, but for everyone who's attended this webinar, you will receive a copy of it so you can have a look through it. And of course, if you've got any questions, you can ask us about it. And it will be available on the website as well for anyone who may be watching this recording. So just first off, before we go into the questions, would anyone like us to contact you for a free consultation. So a box should have popped up on your screen now. If you'd like us to contact you, please press yes. So that can be anything from if you need any help with lighting design, obviously if you've got a project out there, anything like that that we can help you with, just select yes now and we will contact you after the webinar. Okay, wonderful. Okay, so now on to questions. So if you've got any questions, please pop them into the Q&A box, not the chat box. It just makes it easier for us to answer them as we go along. So our first question, what's our take on storing the drivers apart from the luminaire? Who wants to answer that?
I'll answer that. So we have a range of luminaires which have the driver that can be mounted remotely. Let's say we put the divide in which starts to make sense to separate the driver at the master MO4, so at about 450 watt products. Anything above, we make it so the driver can be installed remotely. For example, we install it onto the bracket of the luminaires, but it can be installed even 200 meters away. There's advantages and disadvantages of doing a remote driver installation. The obvious advantage is they're easier to access in case you need maintenance. You get rid of the weight. You can even install them remotely onto the mast as counterweights of the products. For example, if you're installing an 180-degree configuration. Of course, you need to put a little bit more extra care into the installation if you install them remotely, like at the bottom of a mast or elsewhere, because every time you put a distance between the LEDs and the driver, that piece of cable with the DC line in it becomes a receptacle of possible disturbance, or even just the fact that you're joining the cable multiple times could lead to possible installation errors. But it's something we do and we agree on. We don't think it's very viable with very small products. It doesn't make too much sense for us to put a remote driver on a 150 watt lamp on practical terms.
Sophie, I actually have a question which I'd like to ask Paolo, because I think it's something I've thought about, we haven't really discussed. And that is, when in the scenario when a specification or a design is being written for a project, but then the expectation is that project is going to happen in 2 or 2.5 years or 3 years time. And of course, from that time, technology could have moved on, solutions would have changed, suppliers' products would have been upgraded maybe by a couple of, families.
Yeah.
What's the best way, and you probably know who I'm thinking about, and so will some of our listeners, but what's the best way for that type of customer to think about specifying a project?
It's not easy, because I mean, you can't specify something that doesn't exist yet. You don't know exactly which way the market is going to evolve. I mean, definitely, you specify
is that something you just want
minimum
to say?
thing.
Yeah, would you just concentrate on saying to achieve the lighting requirements of EASA or ICA with the lowest cost, but adhering to certain minimum technical standards like IP66?
That's what effectively you do, because you set the minimum standards that you need to reach, but then you make your decision between your suppliers based on cost, on cost, whether it is running cost, the total of running and purchase cost. So effectively, the specifications that you write out today, most of it will still be perfectly viable in a few years. You'll just get it done cheaper and with less running costs.
So maybe you should avoid saying I need 36, 1,000-watt floodlights.
Well, you put
maybe
generally when you specify something like that, you say maximum 36,000 watt floodlights. If you can do it with 2, you would do it with 2.
Well, what if I can do it with 1,200 watt floodlights and only 28 of them?
Okay, you need to set basic rules, because it's not only floodlights and lighting design, but there's a whole electrical project behind it. So you set a range, like, okay, I want about like you put out a project which have 50 fixtures of 1,000 watt, then in 3 years time they might be able to do it with 50 fixtures of 600 watt, and it's only an improvement for you. If you start to say, oh, I do it with half the lights, start to change other parameters of a project. Maybe you wanted to switch half of them off when the apron is not in use. I mean, so it's always appreciated to go down in power and cost for sure, and that's what happens with time.
Yeah. Anyway, let's carry on with the other questions.
Okay, thank you. Our next question, for existing masts, presumably the structural analysis will be required for the mast, as well as the luminaire mounting cradle bracket, etc.
So the structural analysis will be required. It's not always required, depending. Actually, every country has honestly different regulations and rules about this. So it's not that every time you change the luminaire, you need to do a structural analysis of the mast. I mean, actually, sorry, structural analysis, yes. I thought I read the structural survey. Structural analysis, meaning you need to evaluate the weight and the windage. That, of course, when you change the load onto a mast, you need to evaluate that. That's why we're saying, like, it's more simple if your light is always lighter and smaller than whatever was there before, because it goes without saying that your structural analysis will be perfect because you're only reducing weight and windage. The brackets, if you talk about like the crown itself, so like what it's attached to the mast, yeah, definitely those need to be verified as well. Or that's actually the easy part that you could replace in a mast, because if your structural analysis come back saying that the shaft can hold up the weight, but the brackets, the T-bars will not, you can just replace those and keep the shaft in place, which is actually the most expensive and more difficult part to change. The bracket, like the luminaire mounting brackets, if you talk about the ones supplied with the luminaire, that they are, I mean, their structural analysis is done as part of the certification, so it's always the correct one. I mean, at least it should be always the correct dimension one.
Brilliant, thank you. And we have another question. Mast bracket, should they be stainless steel too?
No, masts and brackets are never stainless steel. They are hot dip galvanized. It would be incredibly expensive to have. It would be great to have a stainless steel mast, but it's not. They don't exist. They would be so expensive. So they have a specific galvanization process, which is the same that street poles have most of the time, which creates such a thick layer that it will resist any type of environment. Now you'll say, why don't you coat the luminaires like that? Because the hot dip galvanizing is not a very mechanically precise process, so it adds a lot of thickness, they're all very regular, the surface treated that way. So if you were to make a luminaire with the hot dip galvanized material, it would be very rough product, probably get stuck in the bracket. It wouldn't be a very precise thing. And also with friction, it will come off maybe. So it's not the best. But
okay.
let's say that all the fasteners definitely should be stainless steel. A2 minimum, A4 would be the best, which is the equivalent of 316 steel. So all the bolts and fastener that you use on a mast should be stainless steel.
Wonderful. Thank you very much, Paolo. So our last question is what to choose. Is it better to have lighting poles with a small number of lighting fixtures, but high power, or a large number of fixtures, but lower power?
I like this.
Well, definitely you would go with the lower number of lighting fixtures with certain limits, though. I would always try to avoid 1 or 2 lights on a pole. Go with a minimum of 3, and that's nothing to do with efficiency or anything. But when you do a lighting project for a critical infrastructure, you always have to account for a bad day where things go wrong. And if you have at least 3 fixtures, 1 goes off, you lose 30%, 33% of the light. And that you can almost afford to. While if you only have 1, you're stuck with an entire area completely dark. So generally, yeah, it is better to use less fixtures, but with a compromise. Also, sometimes using too little fixtures doesn't give you the most energy efficient solution, because if you have to hit a certain amount of lux on the ground, and let's say that 2 fixtures are not enough by little margin, adding a 3rd fixture, you will overshoot the requirement a lot. But that's the only thing you can do. Then if you do that for every mast, at the end of the project, you might have too much power installed rather than use 4 of a smaller type of fixture. So it's always a little bit of a compromise, but generally avoid having too many fixtures on a mast is always good.
Okay, wonderful. Okay, we're going to squeeze in one question. Try and make this a quick answer, Paolo.
Yeah.
What can you say about projectors' resistance to vibrations, like in a stadium or in a crane?
So all the floodlights are tested against vibration of, I don't remember exactly the data now, but it is included in the EN 6598, which is the normative for floodlights, which are all reasonable vibration, which you can encounter in stadium on a high mast to make sure that the product doesn't fall apart. You mentioned cranes. Cranes, for example, we do a special certification for it because cranes do vibrate constantly. And the luminaires that go on cranes, they need to survive far stronger vibrations, like 6G, 100,000 cycles, than normal products. So we make a special product, for example, for cranes. It was fast enough.
Brilliant.
Yeah.
Thank you very much. So anyone whose question we haven't got around to answering, we will follow up with you in an email, but that's all we've got time for today. So thank you very much to our wonderful presenters and obviously for all of you joining. On the screen at the moment, you'll see Yuli's and our International Sales Manager Natasha's email. If you've got any questions or anything, please feel free to email them. We do have 2 more webinars coming up in our series. We just haven't secured the dates yet. But by popular demand, we will be doing one on glare control, and we will also be doing one around lighting design and how to read a Dialux report. So we will announce those dates probably next week, and we'll send you an invitation if you'd like to join them. But again, thank you very much for joining us. Appreciate we ran over a little bit in time, but very much appreciate you all staying, and we hope that you found this useful.
Thank you.
Thanks very much. Bye-bye.
Bye-bye.
Thank you, everyone.